In this problem, we need to find the measures of the missing angles, and we can do that by first solving for the value of x and then plugging that value back in and identifying the individual angles. So what we need to remember first is that the sum of the interior angles of any quadrilateral, no matter what the shape, is equal to 360 degrees. So we can take all of the interior angles for this quadrilateral, add them together, and say that they're going to equal 360. And we can clean up this equation a bit, and it'll give us 16x minus 2 degrees plus 3 degrees plus 12x plus 17x plus 3 degrees plus 86 degrees equals 360 degrees. Now if we combine like terms, we'll end up with 45x plus 90 degrees equals 360 degrees. And from there, we can subtract 90 degrees from both sides of the equation, which will give us 45x on the left and 270 degrees on the right, and then we can divide both sides of the equation by 45. This will give us our value for x, and we can figure out that x is going to equal 6 degrees. Once we know that, we can write out the values for each of the unknown angles in terms of x. So we have 17x plus 3 degrees plus 12x, and 16x minus 2 degrees. From here, we can plug in the value 6 degrees for x in each of these expressions. So in our first expression, we're going to end up with 102 degrees plus 3 degrees, or a final answer of 105 degrees. When we plug 6 degrees into our second expression, we're going to end up with 3 degrees plus 72 degrees, which will give us a final answer of 75 degrees. And for our final expression and our final angle, if we plug in 6 degrees, we're going to end up with 96 degrees minus 2 degrees, or a final answer of 94 degrees. And those three measurements taken together will be our final answer.